Piecewise functions are another type of function that you learned in Algebra 1, but I'm going to go over it because a lot of kids seem to forget it. A piecewise function is a combination of equations, each corresponding to a different part of the domain. And remember, the domain is the input value, and it's also the x value. So, what I have here is a piecewise function. Notice it's a combination of equations. I have an equation here and an equation here. But when you graph this, or when you evaluate it, when you evaluate input values that are smaller than 1, you're going to use this equation. And when you use input values bigger than 1, you're going to use this equation. So I'm just going to make up some values here. So this would be given to you if it was a homework problem. I'm going to find f of -1, f of 0, f of 1, and f of 5. So if I use this function, this piecewise function, and I wanted to use an input value of -1. If that was the case, I would go use this equation because -1 is smaller than 1. So I would have 2 times -1 minus 1. So -2 minus 1, which is -3. So I could say f of -1 is -3. Now, this will make more sense the more we do, and once we get down to graphing, it'll tie together. Let's find f of 0. So I first have to decide which function I'm going to use, and since 0 is less than 1, I'm going to use this one again. So I have 2 times 0 minus 1, which is -1. So f of 0 is -1. Okay, let's think about f of 1. Again, on this one, I'm going to use this one because x is equal to 1. So I'm going to have 2 times 1 minus 1, which is 1. So f of 1 is 1. The last one I'm going to try is f of 5. 5 is bigger than 1, so this time I'm going to use this equation. So 3 times 5 plus 1 equals 16. So f of 5 is 16. So if I put 5 into the function, I get out 16. All right, I'm going to skip down now and talk about graphing. So since this is a combination of equations, I'm going to have my piecewise function is going to look a little different in different parts of the graph. If you'll notice, if x is bigger than 3, it's going to look one way, and when x is smaller than 3, it's going to look a different way. And x equals 3 is somewhere right in here. So my graph should look one way on this side of x equals 3, and a different way on this side of x equals 3. So we're going to graph this by making a table of values. So I'm going to have a table of values for the top equation, and a table of values for the bottom equation. So the top equation is going to be the one where I do x greater than or equal to 3. So since it's greater than or equal to 3, I'm going to have 3, 4, and 5. Those are the values I'm going to use for input. The other equation is going to be for when x is smaller than 3. So again, I'm going to use 3 and number smaller than 3. In this particular case, I'm actually including 3, and I'm not here, so I'm going to circle that one with an open circle. And I think you'll see why in just a moment. So since this is the place where x is bigger than 3, I'm going to use this equation. So I'm going to have an input value of 3. 2 times 3 is 6. So I've got the point 36 on my graph. I've got a point right there. 4. 2 times 4 is 8, so I have a point at 4, 8. 2 times 5 is 10, so I have a point at 5, 10. So on this side, the graph is going to look like this. Okay, let's see what the graph looks like when x is smaller than 3. Now I'm going to put in these values. -3 plus 3 is 0. So I'm going to have a point at 3, 0. Now remember, on this one, we did not have a line underneath it. So that one needs to be an open circle. Okay, and then I'm going to try 2. Opposite of 2 is negative 2, plus 3 is 1. So I have a point at 2, 1. And then if I try 1, negative 1 plus 3 is 2, so I have a point at 1, 2. So this part of the graph is going to look something like this. Now, notice we call this a piecewise function. And if you'll remember, a function has exactly one output for each input. So it should pass the vertical line test, and this does. Because if I do a vertical line here, it only hits at that point. So this is that piecewise function graphed. Let's do the next one. So this one has a turning point at 3. So again, I'm going to have a table of values. I'm going to have one table of values for when x is smaller than 3. And then I'm going to have a separate table of values for when x is greater than or equal to 3. So I'm going to think about my numbers here. I'm going to choose 3 and a couple of numbers that are smaller than 3. Here I'm going to choose 3 and a couple of numbers that are bigger than 3. So let's start with the ones that are smaller than 3. That's going to use this equation. Negative 2 times 3 is negative 6, plus 1 is negative 5. Now go put 2 in here. This would be negative 4 plus 1, which is negative 3. And then put 1 in here, so negative 2 times 1 is negative 2, plus 1 is negative 1. So I have a graph at 3, negative 5, at 2, negative 3, and at 1, negative 1. So remember, we're moving away from this line, so this graph is going to look something like this. The other graph, where x is bigger than 3, it will also move away from this line. So let's go plug our numbers in here. 3 minus 8 is negative 5. 4 minus 8, negative 4. 5 minus 8, negative 3. So I have 3, negative 5. I already have a point there, so that's okay. 4, negative 4. And 5, negative 3. So there's the piecewise function. It looks one way on this side of 3, a different way on that side of 3.